Just a minute. It's not operating. You show up. Reboot. Just 2 minutes. The other mobile is not, the chat mobile is not active. I have to reboot it. It will take little time. Because I should see how is the display. Unless that is on, I cannot see it. Just few minutes, 1 or 2 minutes. I just slightly have turn now. 1 minute. I will push upwards. Okay. Now if I turn up to where I can be able to see those values. Further this side. Further. Okay. Everything is okay now. Just send the message fast. Do not delay unnecessarily. You should respond immediately, not too much delay. Okay. Now. Okay. I won't hold the mobile in the hand. In the pocket, you know what happens. Sometimes, like last time, voice fully clear. Voice fully clear. No, voice fully clear. Start. Okay, clear. See, first remember, today we are starting heading right here. Macaulay's method. Macaulay's spelling. Okay, why should you bother about spelling? Macaulay's method. Already double integration method previously we considered. Previously double integration method. Right. This will be discarded now because that method has lot of drawbacks. Now we will come to Macaulay's method. Actually, one of the most important method for deflection. See, suppose you go for moment area method, conjugate beam method, there are lot of limitations. Like some partial UDL, all you cannot solve there because area of the BMD and location of CG required. Macaulay's method is the master method. So study it. Now, first we should make complete understanding how Macaulay's method works. See, remember, this is nothing but modified version of double integration method. It is modified version of double integration method. So equations are same as that one, boundary conditions, everything is same. What all you consider in double integration method, same Macaulay's method. There, see, you make a note. Suppose there is a beam, AB. See here, AB, one extra point C here, one extra point D here. See here, A, B, C, D. They are all standard points. Why? Some people call salient points. I use standard points. These are the points required for what? Defining everything for the beam. Same way. See, A and B and C and D. Therefore, suppose you draw a SFD-BMD variation A to C, C to D, D to B. Even slope and deflection variation from A to C, C to D and D to B. Now, if you apply double integration method, you have take one section here from n section here, valid for 0 to 4 meter. Then one more section you have take here. See, if it is 4 meter, this is 3 meter, this will become 5 meter. So if I take a section here, at x from here varies from 4 to 9. Or if I take x from here, 0 to 5. Next, one more section you require here. Therefore, you will get how many? 6 constants of integration. Deflection at A0, deflection at B0. That's all. Still 4 more required. What do you have to do? Continuity of theta C, comma, continuity of YC, comma, continuity of theta D, comma, continuity of YD. So 4 unknowns, 4 equations, 4 simultaneous equations. To solve it, you may take half an hour. So it will become horrible. If one more point load is there, gone case. Why? 6 unknown. People will throw the question outside. Now, all those difficulties will be overcome in Macaulay's method, where you just take one section. Use deflection at A0, deflection at B0. Your section is such that it is valid for any portion. What section you take is valid for AC, valid for CD, valid for DB. How means I will tell you. So therefore, to understand Macaulay's method, today what we will do is we will go for thoroughly understanding Macaulay's method. Those who want should write. For thoroughly understanding Macaulay's method, today's class we will consider example where we will discuss how Macaulay's method is applied when there are plenty of standard points. That is, by just one equation, how you define it. I will discuss today. See, slowly I will tell one by one. Today's class is very, very important. Anybody who will study deflection from me, Macaulay's method, today is class number 155. Suppose he comes to 156. I will first, or 157, or 158. I will first tell him, first go to 155. Actually, before that, go to deflection starting way. You should know what is scope and deflection. Start everything and go through today's class 155 10 times. Understand. Then only continue. Don't tell suddenly next time, sir, that is not clear. Not clear means leave the class. Why? Coming for subsequent class without studying previous class means leave the class. My class is not for you. Okay, start. Now, one example I will take. Question I will dictate. See, I will dictate the question. Question dictated in the class, write it. And little later I will tell you this beam, speciality of this beam, I will tell you. A beam is simply supported between 2 points A and B 12 meter apart. So one vertical reaction here, simply supported. One vertical reaction here. So later, it is loaded by UDL of 6 kilonewton per meter for the entire span. Partial UDL I will take later. Then also 2 point loads of 108 kilonewton and 100 kilonewton at 4 meters from left end and 3 meters from right end. Okay. Now, in addition, at the left end, there is an anti-clockwise couple of 320.25 kilonewton meter, right end clockwise couple of 336.75 kilonewton meter. I will check this value once again. I will tell you, you don't bother what is going on. 320.25 is correct. Three 36.75 is correct. Now somebody will ask, what is that correct means? You can give any couple. No. This question I adjusted so that reaction will come, that 0.3336667 will not come. Correct value will come. And just for your information, this is actually a fixed beam where both A and B are fixed. If it is fixed beam, see, if the beam is fixed beam, both A and B are fixed, then there is a vertical reaction, reacting moment here, reacting moment MA and MB. So there are 4 unknown reactions, only 2 equilibrium conditions, sigma M0, sigma V0, sigma H is not used. This is statically indeterminate to second degree. So you should analyze this fixed beam and reduce indeterminate state to determinate state. I took MA and MB as redundants. I found it. How I found it, you don't bother. I am giving, for you it's a question. For you it is simply supported beam. But actually it is an applied couple. As if someone is applying a couple. But actually this is the reacting couple developed. Now, therefore, remember, originally this beam was fixed beam. See, if you remember, when the beam, simply supported beam bends, it will bend this way. There will be theta here, there will be theta here. Theta will come. But this beam, later, when you solve, we will solve in the class. Suddenly, to your surprise, tell theta A and theta B, both will come. How much? Theta A and theta B, both will come. Tell how much? Suddenly you will tell, sir, what is this, sir? How it came that way? Theta A and theta B, both will come. How much? Actually, it is a fixed support. Tell the answer. Both theta A and theta B will come. How much? It is a fixed support. Fixed support cannot rotate. No answer. Theta A, theta B, both will come. Later I will tell. When you solve, see, both MA, what is that MA? Slope at A and slope at B, both will come. No MA. Today I am giving applied couple. This is a couple given. I know it is MA and MB. You don't bother about it. That you worry later when you go to fixed beam. But when you find slope and deflection later, slope and A and B, both will come. How much? My guarantee. Both points, slope will come. Because I told you, this is originally a fixed beam. I found it. By what? By compatibility conditions. So later, theta A, theta B, both will come 0. Actually, simply supported, slope is not 0 because this moment will bend it. How? This way it will bend. So that, but you are not knowing, you don't worry. Today for you, it is a simply supported beam with no end couple. Over. Start. First. Step by step right here. To understand Macaulay's method systematically, the given example where there are 4 standard points or the beam is divided into 3 parts or there are 3 parts here. See, AC one part, CD next part, dB next part. Here, what we want is, we want to get bending moment and shear force at different points. Same bending moment later will become deflection. Same shear force later will change over to slope. See, the way you know, M is the bending moment. Shear force is V. V is actually dm by dx. Same way later, Y is the deflection. Theta is the slope. You know theta equal to dy by dx. How M and V are connected here, same way what Y and theta are connected later. Therefore, this example you just calculate or understand whatever I tell in the class. Okay, start. First step. First equilibrium. So you require support reactions to be calculated. Okay, now start. Take moment about A. Remember, those who find difficulty for reaction calculation or finding shear force and bending moment, they should study my class course SFT BMD, where I uploaded up to class number 100. Then I stopped because let people study everything first. Then I will continue up to 100. After 100 was not that YouTube course. After 100 was my BSK course, which was what? Telecast or what? Which was uploaded there just for understanding. Technically, my course SFD BMD 100th class with a special concept, I stopped there. Go through that one, understand. Okay, start. Take moment about A. Moment, direction based, clockwise positive. Minus VB into 12 plus 108 into, earlier I put 72. Later what happened is, when I put 72, this reaction came something 0.33333. I do not want that 33333. So I change it to 108 plus 108, correct it, why bother? 108 into 4 plus 100 into 9, why 9? From 12 subtract 3 plus 6 into 12 into 12 by 2, then not over, plus, oh, this was the earlier moment, plus 336.75 for that couple, no into, plus 3 sigma m is both sides you have to see, minus 320.25 equal to 0, you get the value of VB. Tell me VB value fast. Tell me fast VB value. Fast. Calculate and tell me VB value. Fast. Don't waste time. Calculate and tell me VB value without wasting any time. VB value, fast. I do not want a single mistake today. 148.375. Don't see this value here, because I want confirmation. I do not want 1 micromillimeter error here today. Plus 148.75 kilonewton. Okay, then sigma V0 upward positive plus VA plus VB minus 108 minus 100 minus 6 into 12 equal to 0, not 72, 108. 108. Tell the value of VA fast. Tell the value of VA. These are all numbers which I adjusted to get round numbers. Don't bother about those things. Tell the value of VA fast. Fast VA. Don't make any mistake. Perfect answer required today. VA. VA plus 131.25. 25 kilonewton. Okay. Now, reactions are over. Now, some statement you have to write. I will dictate here. Now, the very purpose of this question is to thoroughly understand how Macaulay's method works, so that when I start slope and deflection by Macaulay's method, these limits for x, or how to substitute, how to take section, that will not be explained again and again. Everything will be told today. Therefore, this is the topmost priority class for Macaulay's method. Those who want to master or understand Macaulay's method, today's class is the topmost priority. If this class is not studied, if they have any difficulty later, they have to blame their self only. Okay, start. Now, statement. What we want is, see, right here. What we want here is, see, so save the time. You write after the class. What I want here. What I want is what we want. Here is to get shear force and bending moment, shearing force and bending moment at all standard points. Standard points. Standard points are A, if I go next C, D and B, or salient points. At all standard points, and also later we want deflection at A, B, C, D. See, what I tell bending moment here is later deflection. What I tell shear force here later will change over to slope. And also at 3 extra points, say P1, P2 and P3. 3 extra points, this is very, very important. P1, P2, P3. Now, where is P1? P1 is at, see, this is 4 meter, somewhere between A and C. P1 is at 2.4 meter from A, somewhere here. Then P2 is at somewhere here. After C, another what? After C, another 1 at 1.6 meter to right of C, or at, I told 1.6 meter to right of C, or at 4 plus 1.6, 5.6 meter from A. Last one, P3, that is at somewhere here, see, 2 meter from B, to left side. Right side there is no beam. So 1 point P1 here, 1 point P2, 1 point P3. Later I will mark it. Now, one note. Now, this is what is required for Macaulay's method. This is what is required for Macaulay's method. And also later, when a time will come, how to find maximum deflection. At that time, principle will be deflection will be maximum where slope equal to 0. Same way here, bending moment will be maximum where shear force 0. That I will discuss as I draw the diagram. Okay. Now start. But however, what we will do is, those who are coming to my class understood. They have gone through all my SFD BMD classes. Yes, compulsory for them. So if they studied, they can draw SFD BMD. So just for a understanding purpose, draw SFD BMD for the beam. Okay. I am not explaining anything. I am not explaining anything for SFD BMD. I will just take my calculator and draw. Because why? Sorry, I cannot explain. I will draw the diagram. If clear, tell clear. Shearing force diagram. 131.625. Oh, this UDL is 6 kilonewton per meter. 131.625. See. Minus 6 into 4. Down to 107.625. Down by 108. It will, oh, there is a problem here. 124. Shearing force diagram is crossing the baseline here. Then there is a problem. Maximum slope will come here only. Okay, 107.625. Ayo. For that I have to change the problem. Yes, I have either have to change the problem or okay, leave it. Maximum we will discuss later what is there. Maximum we will discuss later. The problem is, 1 ನಿಮಿಷ 24. 131.625. Is 131.625 correct? Tell the answer. Is that 131.625 is fully correct? I got doubt. 131.625. Is it fully correct? No, VA 131.625 fully correct. Then 131.625 minus 6 into 4 is 107.625 minus 108. It will cross the baseline here. I don't like it. I don't like it. Okay, I will explain separately. See, I should have taken care. I thought it will cross the baseline somewhere here. Now, actually, I don't know why it happened. 4 plus 5, 9. 9 plus 3, 12. 12 meet this UDL, 100, 108. 4, 3, 5. I think, 108 into 4 into 8 square plus 100 into 9 into 3 square divided by 12 square plus 6 into what? 12 square divided by 12. 320.25 is correct. 100 into 3 into 9 square plus 108 into 8 into 4 square divided by 12 square. 12 square, 5 square divided by 12 square equals how much? Plus 6 into 12 square divided by 12. 336.75. 336.75 minus 320.25 plus 6 into 12 square divided by 2 plus 108 into 4 plus 100 into 9 divided by 12. 148.375 minus 108 minus 100 minus 6 into 12. Oh, I should have kept a little higher UDL. I should have kept a little higher UDL. That's a mistake. I should have made UDL little more severe. Now, okay, no problem. For that purpose, because question already given, I don't want to waste the time. Okay, 131.625. Okay, done. So anyway, unfortunately, shearing post diagram crosses baseline here. I do not want it. It happened here. So what to do? I am helpless. Okay, no problem. So, very small value, 0.375 minus 6 into 5, it will come to 30.375 here. Then come down by 100, it will come to 130.375 here. Again, it will go this way, minus 6 into 3 will be 148.75 here. Who is calling? Odd time. Okay, what to do? Okay, now, shearing post diagram, done. Now, bending moment diagram. This is negative 320.25. This also negative, little more, 336. Why negative is bending moment, 0.75. Here bending moment equal to minus 3. See, when you do bending moment, you can look any side. Minus 336.75 plus 148 minus 336.75 plus 148.375 into 3 minus 6 into 3 into 1.5. It is plus 81 point something here. That much little lesser. This is plus 81.375 here. Bending moment here is minus 320.25 plus 131.625 into 4 minus 6 into 4 into 2 is 158 point somewhere here. Out of scale, 158.25. Okay. Now, joining will be parabola this way, then it will become this way, parabola once again, scale no problem, and one more parabola here. I have not bothered too much about variation, plus minus. Okay, now make a rule. Therefore, I am going to write the result here now. Result. Okay. Now you draw this diagram. Now what you have to do is, see, draw the diagram. This is, remember, not compulsory, just to understand. Okay, done. Can you do it? Just to understand, draw it. Not compulsory. I will tell you what is more important. Can you draw it fast? Can you try it? It is not that much important. Diagram is not important. But just to make perfect, can you try? Just to make perfect, can you try? Our Macaulay's method diagram is not required. Yes. Now, right. What we want is, now see, not result. Right here. And no. I should know up to where I can write here. Maybe up to here. 1 minute, I'll check it. Space problem is there. I should check it correctly. I should complete this side. Why? My hand is not coming. Okay, here. Okay, now I will tell what is required for you for Macaulay's method. Do one thing. You draw the diagram. See the diagram. That's all. See correctly the diagram. That's all I want now. See, start. See the diagram, and now what we want is bending moment calculation. That's all. We want bending moment. Shear force is not required for us. Why? Because our understanding in the Macaulay's method, we write equation for bending moment, not shear force. Therefore, what we want now, see, now right here. Now, right, first right, the diagrams are drawn so that at least some knowledge is gained. Now, what we want for here, what we want now for thoroughly understanding Macaulay's method is, see, bending moment at all 4 standard points. That is at A, comma, C, this is D, and also B. At those 4 points, we want bending moment. And also, bending moment, I think I wrote shear force there. No. Shear force is cancelled. Also, see, also find bending moment at 3 extra points. Shear force not required. Why waste time? Because our class is not SFD-BMD. And bending moments at those 3 extra points. Extra point means random points. That is given points. P1, P2 and P3. All from first principles. All from first principles. Means what? Not by equation. Then I will go to Macaulay's method. First principle. See. Anyway, in class he will explain. As he explains, you correctly understand and get the answer. Later, that is after the class, what all he explained, you write. If you are serious about subject. If you are not serious, leave the class, take rest. Don't come to once again my class. I will tell that way. I want only people who are serious about knowledge. Okay, start. This all I will remove. See now. Some will ask, deflection calculation, Macaulay's method. Why is telling bending moment? Wait. Let it be clear now. and I will tell you equation. Then you will tell, yes, that example is really the master example which will give complete control on Macaulay's method. Start. Now, start here. Start. Start. Okay. Bending moment is sagging positive. I won't waste time. Sagging, positive. Hogging, negative. Sagging, don't see clockwise, anti-clockwise. Hogging, negative. Start. I want bending moment at A. See now. Look this side. You look only one side. And remember right here, since you are doing basic calculation, look any side. But later, Macaulay's method, systematic solution. Okay, start. Bending moment at A, I will look left side. Minus 320.25 kilonewton meter. That's all. No into. If the couple is not there, 0. When I solve simple support beam with no couple, it will be 0. Okay, start. Then, bending moment at C. See now, I am not calculating. You should tell the answer now. Look this side. See, I will look left side. Minus 320.25, no into, plus 131.625 into 4, minus 6 into 4 into 4 by 2. Calculate and tell me the answer. Then, bending moment at D. Better look right side. I will dictate here. Minus 336.75 plus 148.3. See, Macaulay's method, you can't do this way. Their section is taken. But understand first. Minus 336.75 plus 148.375 into 3 positive minus 6 into 3 into 3 by 2. Calculate and tell me the answer. Then, bending moment at B. Come here. Look this side. A, look this side. Look this side. Minus 336.75 kilonewton meter. Over. Now tell, okay, first you get all these values. Then take some other color. Preferably I will take red color. Use some other color and mark those standard points. See, there is a point here called P1. Light line, P1. There is a point here called P2. There is a point here called P3. As per question, this is at 2 meter. As per question, P3 is at, without disturbing here, at how much I told? I forgot. How much I told distance? Yes. P3 is at where? Where I told? I rubbed out. Tell me P2 distance. How much I told? From left hand. For P2 from left hand, how much I told? I forgot. For P2 from left hand. No, P1 is what? Not 6 meter. How much I told P1? No. P2 I told 5.6 meter. Okay. For P1 I told how much? P1. Not 2 meter. For P1 I told how much? Some other number. For P2 I told 5.6 meter. For P1, how much I told? 2.4 meter. Okay. 2.4 meter. And for P3, from right hand, I told 2 meter. Yes or no? Tell me. Tell correct. For P3, from right hand, I told P3, I told 2 meter. Tell yes. P1 I told 2.4. P2 I told from here 5.6. Or from here how much? 1.6. Or from here to here is 1.6. Okay. Yes. Okay. Now, correctly calculate now. Start. Next. Macaulay's method more important. Now, BM at P1, P2 and P3, they are randomly given points. Start. BM at P1, look left side. BM at P2, also look left side. And BM at P3, look right side. Okay. I will explain. You should tell the answer now. See, start. I will explain. I won't write now because I will take a small break at that time. See correctly now. BM at P1, look this side, minus 320.25 plus 131.625 into 2.4 minus 6 into 2.4 into 2.4 by 2. Start. Calculate and tell me the answer. BM at P2. Remember, this is 1.6 minus 320.25 plus 131.625 into 5.6 minus 6 into 5.6 into 5.6 by 2 also minus 108 into 1.6. Tell me the answer. P3, look this side, minus 336.375 plus 148.375 into 2, that is positive, minus 6 into 2 into half of 2, that is 1. Calculate BM at P3. Now, A and B, I know the answer. I will come in 5-6 minutes. By the time I come, you have ready with answer. You type this value, these two values, then put a slash. Actually, I will tell you one more thing. BM at C, you can get by bending moment diagram only. See here, plus 158.25. So, and BM at here will come plus 81.375. Check this one. Check these values. This is to be checked. These three values you have to type. Don't type this value. Why? It is there in the bending moment diagram only. Okay. These three values you have to tell me. Later, Macaulay's method, we will get all these. Today's class, bending moment by a single equation. Remember, actually, if you go to basic, you need 3 sections here. No, we will get it by a single equation. It's a wonder. By adjusting the terms, I will get all this value will come today by Macaulay's method. The way Macaulay's method, today bending moment, later it is double integration, it will go to deflection and slope. Okay, start. Tell me these three values. I'll take a small break. By the time around 5 minutes I come back, I want these three values to be typed. Okay, start. Don't waste time. By the time I come back, I want those three values. Okay, start. No waste of time. We'll start now. You gave the answer. I want full number, not 1 micromillimeter difference. Okay, let me get the values first. Let me first get the values and write it. Okay, see. Now, what I will do is, I will, see, this beam reactions I am rubbing. I am rubbing the reactions. Why? It is not required. Okay, then I will write the results here, what I got. So that the purpose you can make out later. Little later you can make out why this, some will tell surely. Deflection of beam is doing, he is telling bending moment. I will tell him, don't hurry, I know correctly. See, I will write the result here. See, results we got. Result by basic principle, basic concepts. Basic concept, no section XX. Results from basic concept, that is, no section XX, nothing considered. Sections are not considered because in Macaulay's method we need sections. Okay, I will write the answer here. See, I will write all our bending moment values. All are bending moments in kilonewton meter. At A is a standard point. See, C is a standard point. I will round off. D is a standard point. B is a standard point. These 4 are standard points. Okay, see, right. At A, bending moment minus 320.25. At C, how much you got? Plus 158.25. At D, 81.375. At B, 336.75 minus 336.75. And then there are 4 random points are there. 4 random points. Those 4 random points, see correctly, one of them is P1. P1. That is at how much distance? 2.4 meter from here. Their answer is how much? I have to get it now. One more point is P2, which is from left end at how much? 5.6 meter. Their answer is, red color I am showing. See, random point XX, random, X, red color. One more point is P3. P3 is told at 2 meter from here. Their bending moments are, at P1 it is minus 320.25 plus 131.625 into how much? 2.4 minus 6 into 2.4 into 1.2. 50.37. Is it correct? 50.37. I don't know. My calculator problem. 1 minute now. Minus 320.25 plus 131.625 into 2.4 minus 6 into 2.4 into 2.4 by 2 is minus 21.63. Is it correct, your answer? Very good. It is minus 21.63. See, this answer is, where is the answer? Minus 21.63. At P2, look this side. Minus 320.25 plus reaction 131.625 into 5.6 minus 6 into 5.6 into 5.6 by 2 minus 108 into 1.6. It is plus 149.97. Same answer from you also. Plus 149.97. Yes, correct. So you will get plus 149.9. I am not writing because this is BMD. My course is there to study. Last point, BM. Minus 336.75 plus 148.375 into 2 minus 6 into 2 into 1 minus 52. It is minus 52 is the answer. What about your answer? minus 52, correct. Okay, now we got correctly bending moment at all the standard points and also those random points in between, all from first principles. No section XX, nothing. Okay, now start fresh now. See, now come to Macaulay's method. See, now come to Macaulay's method. Okay, red color I am using. Okay, red. Macaulay will be, why red color? Just like that. Now start Macaulay's method. Note, thorough understanding of Macaulay's method. The first step is thoroughly understanding expression for BM. That is MX. Bending moment at section XX at X from origin. X from origin. X from origin, then in double integration method, there are 3 parts, 4 standard point. 4 standard point means 3 parts are there. So if you do by double integration method, you need 3 sections, one between A and C, valid from 0 to 4, one more section here. If I take from here 4 to 9, if I take from here 0 to 5, one more section here, X from here 0 to 3, or if I take from here 9 to 12. And when you double integrate it and slope and mean during that, one first integration gives you slope equation, second integration gives you deflection equation, then there will be total 6 unknowns are there. And only 2 standard boundary conditions, deflection at A0, deflection at B0. To get furthermore equation, you consider theta continuity at C, theta continuity at D, y continuity at C, y continuity at D, and struggle. Maybe after 1 hour you will get it. But now the striking advantage of Macaulay's method. Even though there are 3 parts here, 4 standard point means 3 parts. Remember, if there are 4 bus stops are there are 3 journeys, not 4 journeys. 4 standard point here. It can be any more. If it is one more point, double integration is gone. Macaulay, no problem. So what? Even though 3 parts are there, we are going to consider only one section. That is the super advantage of Macaulay's method. How? I will tell how it is done. See, you consider only one section. Okay, I'll remove everything now. See, I will first explain to you how are the sections. See, how are the sections? Correctly, first you have to know. As I tell here, today you understand. Later you write, after the class, write everything. Once you understand today's class, if by chance some difficulty means tomorrow you can continue, no problem, nothing to hurry. Once this example is fully clear, then you will enjoy Macaulay's method like anything. There will be nothing then. You can finish also very fast. Why? The what is more important is covered now. See, now what I will do is I will sketch the beam once again. See here, with the reactions. This is the beam. See, this is the beam. There is a reaction here of VA equal to, tell me the VA. Hi, I rub the VA value. What is the VA value? Oh, what is the VA value? Tell me. I've rubbed it. VA equal to 100 and VA 100 and VA 100 and. Oh, where is it? Complete remove it. VA value 131.625 kilonewton. There is a VB value here of, what is VB value? Tell me also VB value. VB value 148.375 kilonewton at A anti-clockwise couple of, I can see there, 320.25 kilonewton meter. At B, this is a B point, clockwise couple of 336.75 kilonewton meter. There is a standard point here C, where there is a point load of 108 kilonewton. There is one more standard point here D. It is a standard point. Okay, that is 100 kilonewton. UDL is 6. I'll put somewhere here. UDL is 6 kilonewton per meter. Okay, now distance wise, this is, see now correctly, I'll put distance here for some reason. This is 4 meter. There's a reason for it writing here. This is 5 meter. This is 3 meter. Fully clear? This is standard point A, standard point C, standard point D, standard point B. Extra point or standard points, I will round off. I will round off standard points. There's a reason for that one. Later I will not round off this way. I will round off. Extra points I will write by light black color I will write. Extra point I will write black color. That not red color. XX is the red color section. Okay, now every concept you have to write. If you want to thoroughly understand, everything to be written. No lazy business in my class. Start. Now I want, okay, this is red cover, this is 4 meter, 1 meter. 4 meter, okay. This side, throw it outside, not required. One black I require now. Okay, now, random point, I use black color. Okay, now what you do is, now you have to get in the double integration method or Macaulay's method, you have to take section XX. See now, what you do? First, see, I will write here. Take A as origin. Origin. Okay, today I will explain A origin. If you want tomorrow, I will continue and take B origin and explain for you later tomorrow. Okay, start. Take A origin and consider section XX between A and C, between the standard points. What? Standard points A, the standard point is blue color here. Today, standard point is blue color. Between the standard points A and C, comma, at X from origin A. Origin A. Okay. Now, A will become origin. Take a section here, XX, at X from here. Okay. Now I want what is the bending moment. Now tell me answer. This section is the bending moment at XX. That is MX. Sagging positive equal to, see here, minus 320.25. I can use black color. Plus 131.625 into X minus 6 into X is the total load into X by 2, 6 into X by 2, or I will write directly today, time is not there, 6 into X by 2 is X square by 2. Now tell me, this equation is valid as long as section is after A till the point C. This cannot be used beyond the point C, because the moment you go beyond C, then apart from this one, also 108 will come. Clear or not? If you go beyond C, that is beyond 4 meters, apart from this term, 108 also will come. Tell yes or no. These all you have to write. Those who want control, everything I tell you should write. Each and every word. If I go beyond C, if I use this equation beyond C, then 108 also will come. Therefore, this you can use only for AC portion. X should be from A, and that all you write. That X value varies from 0 to how much? 0 to, answer. 0 to, fast. 0 to That x value varies from 0 to limit. X is from A, 0 to 4. 0 to 4. Okay, start. Now, in this equation, I can find BM at A, I can find even BM at C, and also I can find BM at that extra point P1. That's all. Start. Substitute x equal to, tell me, I want what? I want to find BM at A, I want. Then I want BM at C. Then I want how much? I want BM at that extra point P1. Sorry, I will mark the point P1. Where is the point P1? Okay. P1 I will put later. You can see there, sketch. You can, my dear, there is a point called, see, extra point called P1 here at a distance of, this is x actually, at a distance of how much? 2.4 meter here. X can be anywhere. P1. Okay, now tell the answer. If I want BM at A, substitute x equal to. If I want BM at C, substitute x equal to. If I want BM at P1, substitute x equal to. For A, 0. For C, substitute x equal to 4 meter. And for P1, substitute x equal to 2.4 meter. You substitute and get the answer. Therefore, you get BM at A equal to substitute, BM at C equal to substitute, BM at P1, extra point P1, see, that P1 point, you substitute. Tell the answer. First, when you put 0, it comes to minus 320.25. When you put x equal to 4 meter in this equation, substitute, you substitute, answer. When you put x equal to 4, fast, don't waste time. Substitute. Substitute x equal to 4, answer. Don't waste time now. Substitute x equal to 4, answer. Plus 158.25 and substitute x equal to 2.4, you are getting minus 21.63. See, correctly answer came. Yes, at A correct, at C correct, at P1 also correct. Right means verified. Clear? Right means verified now. Okay. Tell me, fully clear or not? Fully clear or not? First tell me. Fully clear or not? First. The limitation is x should be equal, x become 0. Now, in this equation, can I put x equal to 9 meter? Tell me. Can I find bending moment at P2 at x equal to 5.6 meter? Can I do it? Tell me. No, because at that time, it will give wrong answer. Suppose you substitute here, you do one thing. Just curiosity. Anyway, one should tell the limit is 0 to 4. Beyond 4, you can't go. Suppose you go, you will not get this answer. Some wrong answer will come. Clear or not? Some wrong answer will come if you go beyond that one. Okay, start. Now, right, AC portion clear. Now, once again, take A only origin. Consider x, second round now, second round. I am not rubbing. Consider section XX between the standard points C and D. C and D at x from origin A only. Not here. Now 2.4 is gone. See, not here. You take a section here. See, take a section here. Now 1 minute now, take a section here, XX. 1 minute now, when I took A, when I consider AC portion, my MX came, see, a 0 to 4 variation, my MX came, how much? Minus 320.25, then plus 131.25 into x minus 6 into x square by 2. This is already over. X square by 2. Already over. Now, when I consider CD portion, see, AC, x from A. CD also, x from A only. I will take x from A only. See, x from A. Okay, now, see here. Now I want bending moment. X from A. Therefore, now the bending moment is, see here, minus 320.25 plus 131.625 into once again x minus 6 into x by 2 will come, but also minus 108 into what? Tell me. 108 into this is x, this is 4 meter into x minus 4 will come, into x minus 4 will come. Clear or not? See, when I do bending moment here, minus 320.25 plus 131.625 into this new x minus 108 into x minus 4 will come. This x is after C, see that x is, you can write a note here, that x is after C, but it is anyway, after C means C also will do, and before D. So that x value is valid from, so this is valid for x, tell me, for x range. It is valid from C to D. So when it is C, x is from A, x equal to 4 meter. Valid from 4 to, when you go to D, remember x is from A only. Tell the answer. It is valid from, starting point is from here to here is 4 meter. Ending point is from here to here. How much? Tell me. Not 5. Tell the limit. Valid from 4 to 9. It is valid from 4 to 9 meter. Okay, start. Now, I want once again BM at C. I want BM at D now. Then I want BM at P2. Where is P2? P2 is at 5.6 meter from A. See, there is a point P2 here. See, there is a point P2 here. From here to here is 5.6 meter. Okay, now start. To get BM at C, now it is varied from 4 to 9. Put x equal to 4 meter. You get BM at C. To get BM at D, put x equal to 9 meter. X equal to 9 meter. You get BM at D. D. This is CD. Then, to get bending moment at the point P2, put x equal to 5.6 meter. You get BM at P2. Substitute, not required. Start. Substitute x equal to 4 meter. You try later. Your answer will come plus 158.25. Next it will come plus 81.375. Then P2 it will come plus 149.97. Tell me yes or no, fast. Will it come or not? You substitute later, no time now. Will you try later? Will it come or not? Tell the answer. Will it come or not, I want. I just want. Will it 149.97, 158.81.375. Correct. Therefore, I will write here now. Result by what? See, I am rubbing here. AC 0 to 4, x from A. Now I am rubbing this one now. And when I consider CD, then x is from what? X is from A only. Here where is from 0 to 4. This where is from 4 to 9. My mx equation came, I write here once again. It came minus 320.25 plus 131.25 into x minus 6 into x square by 2 also minus 108 into x minus 4 came, and then when I substitute 4, I got this bm once again. When I substitute 9, I got this bm also I got. When I put x equal to 5.6 meter, I even got this bm also. Thoroughly clear means tell me the last part now. If thoroughly clear, tell the last, I got last part. Thoroughly clear? This is the beauty of Macaulay's method. See, later you'll understand why Macaulay's method is a really brilliant person. How he thought, first of all, I don't know. How it idea came to him. The people struggling by double integration method, suddenly after Macaulay, everything was simplified. Okay, now, lastly, I'll write here now. Lastly, third round now. Third round. Take once again A origin. You write once again section. Now P2 gone. Once again section. This time, take a section XX here. But remember, even now, X should be from A only. In Macaulay's method, only one origin. A is your origin. Consider XX between which point? Standard point D and B. At X from origin A. So, this is valid for X after D and till B. Or your BM will come now, see here. Plus minus 320.25 plus 131.625 into once again X minus 6 into X by 2 again minus 108 into here bending moment this is X, this is 4 minus 108 into 108 into X minus 4, X is red color, X minus 4 not over again minus 100 into, see, this distance from X subtract 9 meter, X minus 9, X minus 9. Okay, now I'll write here. And later, when I consider dB portion, I took once again X from A only, A, and it varies from, see, D means X equal to 9 meter from A, B means X equal to 12 meter, varies from, X varies from what? 9 to 12. Then my MX equation came, see here, I am copying, minus 320.25 plus 131.25 into X minus 6 into X square by 2 minus 108 into X minus 4 also minus 100 into X minus 9. And now, if I want BM at D, D is here. If I want BM, it is valid from D to B. If I want BM at D, substitute X equal to 9 meter. If I want BM at B, substitute X equal to 12 meter. And if I want BM at that point P3, that is at what? That is at 2 meter from B. Therefore, tell me how much meter from A? That P2 is 2 meter from B. That you cannot write. Tell me how much meter from A? I want A only. From A how much? Because I want distance from A, not from B. They told 2 meter from B, 10 meter from A. That is 10 meter from A. Therefore, substitute X equal to 10 meter. You get BM at D, you get BM at B, you get BM at P3. I will calculate first. See, this is a calculator. I will use other side of calculator. Plus 81.375 minus 336.75 minus 52. Oh, same answer, and same answer. Tell me, yes or no? You try later. Correct or not? Correct or not? Tell the answer. Correct or not, you tell. Coming or not coming? Coming or not coming? If it is not coming, got the same answer. Okay, thank you. Now, you make a note. Observe the equation for all three sections. You should write. Tomorrow I will not tell once again. Whether you want for AC, whether you want for CD, or whether you want for DB. AC is 0 to 4, CD is 4 to 9, DB is 9 to 12. Wherever you want, your X is taken from only one origin. Therefore, as you go further and further, previous terms are maintained. Previous terms are maintained. New terms started adding. See, this is for AC. When I do for CD, that is once again there. What you got here repeated, and a new term came. And when I want for DB, whatever CD is there, that repeated. And one new term came, that is for DB. So, as you go along the beam, if you take origin from same point for different parts, expression for BM will be some expression for first part. When you go to second part, same expression plus addition. When you go to one more part, again same expression plus some addition. Or the addition term will always have a bracket. The addition term will always have a bracket in the form of x minus something. Yes or no? In the form of x minus something. That something is always the previous limit. See, A to C there is no bracket. After C, after 4 meter, the extra bracket is x minus 4. After D, the extra bracket is x minus 4 already there, x minus 8, not 8, x minus 9. X minus 9. Or the bracket term will be x minus the previous distance. Tell me, fully crystal clear or not? Tell me, fully crystal clear or not? Fast I want. Calculated, no jokes, sir. I am not calculated because I got confidence. Bending moment in my class not tallying means how I can take the class first of all. Fully clear. Okay. Now I will tell you the Macaulay's method advantage. I will tell you now only if you want. In the question, you take A origin, take section here. If I take left hand origin, take section between the last 2 points on the other side. Or if I take B origin, take section between the last 2 points on the left side. Write equation for BM for the entire beam. Then, when you substitute boundary conditions, you decide whether X is applicable or not. How to decide, I will tell you in the class, or crude method is there. Anybody know it? When you substitute a value of X, if that term inside the bracket, X minus something, if it gives negative sign, means that term is non-applicable. See, this term is not applicable for X less than 4 meter. This term is not applicable for X less than 4 meter and also less than 9 meter. This I will tell you tomorrow, and this I will still maintain. I will remove all this. Before your class I will write here A origin section here, B origin section there. Clear? And make complete clarification. That is negative neglected is the crude method. Correct method is, see, if I want to put X anything after 4, then before 4, X minus 4 will not come. If I want anything before D, X minus 9 will not come. Why? This is up to 4. See, this is up to 4. this is above 4 up to 9, above 9 up to 12. That is the beauty of Macaulay's method. So tomorrow in the board, left side I will write this question with A origin before the class. Right side I will write same example with B origin, and then I will show all this BM calculation. It will come, this value I will write. See, for your information, previous class we solved by double integration method. See correctly in the board. See the board there. I will turn the board here. See the board. I noted down all the answer there. Are you seeing? I noted down all the answer we got last time by double integration method. Theta A, theta B, theta C, YC, theta D, YD, theta P1, theta YP1, theta P2, YP2, Y maximum. Can you see it? I noted down before rubbing the board. I have not used the board there. See there. Right side, I noted down. Can you see it? That was our question by double integration. Yes. We will solve the same question by Macaulay. So that how much time it took last time, this will not take more than even 25% of it. It will not take time more than, suppose there are 3 standard points are there, Macaulay will give you only 10% time. If 5 point notes are there, Macaulay will take only 10 minutes, that will take 10 hours then. Therefore, I see when I wrote the answer last time, I have confidence. What? It will come today, next time also, it will surely come. In my class, answer has to always come, which you agree, you know by this time. Okay, now, okay, tomorrow I will conclude Macaulay's method, and very important, I will solve that problem of 10 meter span, I think 60 kN load at 4 meter from left end. EI was 40,000. Tomorrow I will fully solve it, and after solving, I will turn the camera and ask you, see the answer we got, or take a what? Snapshot of this one. See that answer, you take a snapshot. Take a snapshot, that answer. Then take a screenshot. Tomorrow I will ask you, now tell me the result we got earlier. You have tell everything is same. Okay, thank you. See you tomorrow. Tomorrow will be Macaulay's final what? Part of Macaulay's explanation, maybe 10 minutes. Then we will start that problem by Macaulay, and hopefully tomorrow we will finish that problem also. Then we will tell, oh, Macaulay is nice method. Double integration is a bad method. As the number of standard point becomes more and more, double integration becomes more and more bad. Macaulay, you will tell, no problem. Any number of standard point, nothing to worry, because we only one equation. Only one equation. Okay, we'll continue tomorrow. Thank you. Thoroughly study today's class.